Oh, hello, everybody. Let me get started with what I need to share for today. We need to share PyCharm, and we need to share Google Chrome. And so let's go ahead and get started since my clock just ticked to 4. Administrative notes. First, apologize for the confusion on the lab. I did not go back and ping Kevin and Mariah and let them know that today's lecture is for loops. You should have no problem doing the lab after the material from today's lecture, or let me know if there's a problem or whatever. And I need to make sure I'm syncing with them better than I was this past week. I apologize. I got busy and didn't make sure they were exactly up to speed on the schedule. So that's on me. We'll make sure that doesn't happen again. The one thing I did want to talk to everybody about and make sure you're aware of is that our first exam, unlike the majors, we are not following the major schedule for exams or types. Okay. Our first exam, that's a typo. Number 2, no, sorry, that's test number 1, is 2 weeks from today. It is Wednesday, March 3rd. It will include all the lecture material through next Wednesday. So today, next Monday, and next Wednesday, we'll have for loops and while loops, and that will be what's on our first exam. We are currently scheduled that if we've caught up with everything, that Monday, March 1st lecture is going to be your review for the exam. And I'll put a sample exam out on Blackboard sometime at the end of next week. It'll have the same type of number of questions as are on the actual exam. So the way the exam will work is it'll be on Blackboard. You'll have time to do it. I know there are several of you who have accommodations through SDS. I will contact you ahead of time to make sure we make arrangements for that. Don't worry about it. We'll get that taken care of. I do not use lockdown browsers, cameras, or anything else. This is essentially an open book exam. I will, during the exam itself, be online on a WebEx session like this. You can join or not as your choice. That's if you have questions. If you don't understand a question, if you don't know what I need or something else, then I'll be available on WebEx during the exam. We take them live. The majors exams are essentially take home. They're given and then they're due a few days later. That's not how we do it. We do it in the 90-minute session during the exam on Blackboard without a lockdown browser. So that's, there'll be more on this as we get closer to exam day. But for planning purposes, if you don't remember, if you haven't seen the schedule, that's what we got 2 weeks from today. Homework number 2 is due next week. Remember, it's not due Friday as it is for the majors. You have until next Monday. But again, as you can see, work starts to pile up, so you should stay on it. Okay, so with that, we want to talk about for loops. Now, in terms of program control, and I apologize, this slide did not get put on GitHub, but I did want to explain a little bit of background. So we have types of program control, how a program executes, how you execute one statement than another in a program. The default and the first thing we taught is sequential program control, okay? One statement executes, then another statement executes. A statement is something that Python can do, like x equals 5, print y, or something like that. That's a statement. So in sequential control, you do statement, then next statement, then next statement, then next statement. That's just sequential. It's a sequence, one after the other. We have since covered conditional control. That was our second type. Conditional control is you do a statement or a set of statements only if some condition is true. It's an if and if then, if and if else and if else. Those are conditional control. If something is true, you do something. Else, you do something else as an option. That's conditional control. Today, we start iterative control, the third type. Iterative control is you execute a statement or a set of statements multiple times, over and over. And the two ways that Python has to do iterative program control are called for loops and while loops. And today's lecture is for loops. Next Monday we'll continue, and by next Wednesday we'll have finished everything. So this is iterative program control. Okay, for loops allows us to take.
Professor?
Yes, go right ahead. I'm sorry.
Are you recording?
I thought I was. Let me double check.
Oh.
Thank you for pointing that out.
No problem.
Okay, let's see. It says I am recording.
Okay, good.
No problem. Yeah, always ask, because I know there's a couple of people who, because of commitments with UMBC athletic teams or other things, I know there's a couple of people who rely on the videos. So if I'm not recording, that's bad. So thank you. Okay.
Professor?
Yes, go right ahead.
I wanted to ask, so for the exams, will it just be the multiple choice sort of thing that we do in 90 minutes? That's it? That's what the...
No, it is multiple choice. It is short answer, which I structure as essay questions in Blackboard. And there are also some programming, which I also in Blackboard structure as essay questions.
Okay. All right.
So there will be all of them.
Okay. How many questions approximately will we get?
Let me real quick give you an example. I'm going to go to the old GitHub. If you want to fool around with it, you can. On the class GitHub site, if you go to the fall 2020 repo, you can look at, where did I have them? I have to look and see where I had them. I think they're under assignments. Those are the homeworks. No, it wasn't there. Okay, where did I have them? Code samples, lecture notes. The sample exams from last semester are available, and you can start looking at them now. And I gotta find where I put them. Sample final answers, etc. Okay, they're here somewhere. I have to figure out where I moved them all. Okay, I moved them all somewhere. I'll figure out, and I'll put out a thing that says where they are.
Okay.
But you could start looking at them now to give you. The short answer is the exams were 75 points. Typically, there's 15 multiple choice questions, which are worth 3 points each. That's 45. I'm sorry, 10. There's 10 multiple choice questions, which are worth 3 points each. That's 30. There's 2 programming questions for 10 points each. That's 20, makes 50. And then typically about 5 short answer questions, which will bring you they're 5 points each, which will bring you the other 25. So it's like that.
All right. Thanks.
Okay. No problem. So the longer ones, the 15 true false was the final, but that's 4, so we take that. Okay, anyway, for loops. So for loops go with lists, and that's why we teach them all together, and that's why last Wednesday, Monday, and this Wednesday lecture is really kind of, you need all 3 to get stuff done. Last Wednesday and Monday, we did all about lists and some strings, and today we do for loops, and it ties things up. And you can write code that will do something for every element in a list. Now, you have a special case that we call a for each loop, is when you want to do something with every element in a list exactly once. Or you can have a more general case, which is called a for I loop. And so I want to just jump directly to some examples. Now, in today's coding file, which I'll post when we're done, I have declared the list of states to be a constant. Remember, Python does not really... Have I dropped? Hang on a second. Somebody let me know if I'm still online.
You are.
Still online.
Okay, good. I'm getting a very strange pinging from okay, my problem is I have 3 computers going at the same time, and apparently my work computer just started this hideous pinging noise, so I'm going to ignore it for now. All right, and get back in. So, anyway, here is a constant called states. This is a constant because I'm not going to change it. I'm not going to add DC or Puerto Rico, and I'm not going to delete anything like I did last time. So I have a constant, and I signify that with all caps. So this is states. Now, suppose that I want to print each state in the list states on a separate line. How do I do this? Well, this is what we call a for each loop, because I'm going to print each state exactly once, and the syntax is this. The word for, now I'm going to make up a variable name. I need to use a new variable name, so make one up. Remembering that Python is case sensitive, state in all small letters is indeed a brand new variable that's not used. Then the magic word we talked about last time, in states. This has to be a list. So this right here has to be a list. Well, the only list I've defined is states, so that's fine. Now, as I said, this is a constant. It could be a variable. It doesn't matter. This just has to be a list. So it's the word for, a new variable in a list, colon. Now, white space indentation is important. Just like with an if statement, anything under a for, anything that's indented is going to be executed as part of the loop, and then what's not indented later on is not part of the loop. So in this case, to print each state on a separate line, I'm simply going to say print state, and remember the print statement prints a new line at the end by default. And now out of the loop, and I'm going to put a comment here that says now we're out of the loop. So unindented, print, we're done. So this is my for each loop. Okay, see? And you can see that what we've done here is gone through and printed each element of the list one at a time on a separate line. And then this last line is just to indicate that we're out of the loop, we're through, we don't have to do this. Okay, let's go back and look at this code again. This is the entire loop. This is how I print every element in the loop. For state, in states, print state. What happens is Python assigns this variable each value in order. So going back, Python says state is Alabama, do something. Now state is Alaska, do something. Now state is Arizona, do something. Now state is Arkansas, do something, and continues on. So this is a for each loop. It causes what's down here in the loop to be executed exactly one time for each value in the list, for each, exactly one time. So for state, in states, print state, and then just to show you, we are out of the loop when we are unindented. If I wanted to do something else that was indented, okay, This would be in the loop. So let's execute this. This is just to show you that the indentation, again, Python is strange among computer languages in that the syntax matters, okay? What happened is, here it is. This code right here said, for state in states, state gets the first value in the list, Alabama. Print state, print Alabama. Print next state end equals colon. That's what causes this next state colon blank space. Now it stops right here. State gets the next value, Alaska. Printed it, move to the next. State gets the next value, Arkansas or Arizona. State gets the next value, Arkansas. State gets the next value. And so the point of this is because these two things are indented, they are both part of the loop and they are both executed every time. Now you can see that this is probably not what you want exactly for formatting, because after state is when state is Wyoming, we print Wyoming, we print the next state on the next line. Now we're out of the loop because we've done all 50 states. Out of the loop, we come and execute this. We're done. Well, after this last print statement, this left, we're done on the same line. Okay. So this is a for each loop. A for each loop, you define a new, you use the reserved word for, you define a new variable, anything you haven't used before. You actually can reuse something as long as you're careful. In states, print, in this case, the state, and then print something else. So this is an example of a for each loop where we do something exactly once. Okay, go back to the slides. With my grocery list, I give it another example, print it one line at a time, and this is an illustration of what's working. Okay, in this case, it was print the items in a grocery list rather than the states in the state. The syntax is exactly the same. Reserved word for. Make up a new variable name. In this case, I called it item because I was dealing with items in a grocery list, not states in a list of state. That's fine. In. And then in this case, any list, whatever list I want. This is a list as a variable. In the example I just did in PyCharm, I used the constant states. It doesn't matter. If you look at this, remember that in is returns a Boolean. In returns true if this is in this. So the way the for each loop works, it's going to assign every possible value that's true. Okay. And then you end with a colon, just like an if statement, you end with a colon. And then in this case, the loop, just like what I did in PyCharm, just says print. Okay. And a note, my note here in blue, indent, just like with if else, the white space is important. This is a Boolean. What this means, a new variable automatically creates this to be the same type, and then go through giving every value in turn in the list. So that is a for each loop. The other kind of loop is when you may or may not want the value to be you may not want to do something with every element in the list. And so you use what's called a for I loop. Now, for I is an informal notation because a lot of times you will use the variable I here. The syntax is, again, the word for, and then a variable, which is an iterator. It's going to iterate one through the end of something. And often we use I, and I'll give you an example of that. In, again, now here is what's key. You use the term range, And then you can give range anything from 1 to 3 values. Range means here are all the different values I want this to take on. And then do something. Let's go to PyCharm and illustrate this. Suppose that I want to do the same thing as above. It helps if I have a comment. Do the same thing as above using a for I loop. Here we go. For I, any variable going to be used as an iterator. A lot of times we just use I because it makes sense for I for 1, 2, 3, 4, whatever. In range 0 length of states 1 colon print states sub I print next state comma end equals colon blank space. Now we're going to unindent to be out of the loop. Print we're done. Okay, so this loop of code is going to do exactly what the other one did, and we'll show you that. You can look at that output and you will see that it is identical to the other program output. Okay, so I've done the same thing. Okay, that's cool. If I had one way of doing it, why did I have the other one? The answer is because this is more general, and we'll get to that in a minute. I want to talk about, and this is what's in the slides, these values here. 0, length of states, and 1. Remember that length of states tells you how many elements are in the list. Okay. What this syntax is this in the slides I called it A, the first value. This is the starting value. The first time through the loop, what I want to do is set I to this value. Set I to this value the first time through the loop. That is the syntax here. For I in range, start at 0. So the first time through the loop, I'm going to say print states sub 0 because I equals 0. This middle value says stop when I gets to be here. Now, just like with the previous examples on Monday, do not do anything when I takes on this value. So length of states is 50, right? There's 50 states, so if I didn't mess something up, my constant has 50 states listed and the length of states is 50. Do not execute when I is 50. Let's try this again. Start when I is 0. When I is 50, do not do anything, which is good because there is no states sub 50. It would be an error. And this value says increment I every time by this. For I in range, start at 0, increment every time by 1, and stop, do not execute when I equals 50 because length of states is 50. So what this says is print states sub 0. Then do this line. Now increment I by 1. 0 plus 1 is 1. So that through the loop, print states sub 1. And this. Increment by 1. Print states sub 2. Increment by 1. Print states sub 3. Keep going. Now, print states sub 49. It does that. That's Wyoming. This is states sub 49. Now print this thing on the next line. Now states equals 50. Our length is our I equals 50. 1 plus 49 is 50. So now we say stop, right? Because length of states is 50, I is 50. Do not execute when I has this value. Okay. So that's our stopping point. So these three values, and let's go back to the slides. The three things that are important is, let me see where it was supposed to be. I put my slide in the wrong order. Okay, here, this is where I want to go. So I said range ABC takes three parameters. The starting point, in the example in PyCharm, start at 0. Where you end, you do not execute when it takes on this value, and what we call a hop size, an incrementer count. Okay. Now, I have a note that this does not actually have to be integers. All the examples we're going to cover are going to be integers. At some point, probably next Monday, I'll show you the other way. But for now, we're always going to use integers. Okay. If I said for I in range 0, length of states to 1, suppose I said for I in range 0, length of states 2, colon. And I'm not going to do the new thing. I'm just going to print states sub I. Let's execute that. You get the importance of indentation and unindentation, so I'm not going to put the rest of the code in here. It looks ridiculous. Now what we see is we print every other state, right? Because we started with I equals 0, so we printed Alabama. Then we incremented by 2, so we skipped Alaska and we went straight to Arizona. Then we added 2, and we now have I equals 4, so we skipped 3. Alabama, Alaska, or I'm sorry, we started 0, we skipped 3, Arkansas, and we went straight to California. Then we incremented by 2, and we skipped Colorado, and we went to Connecticut. So the hop count is important because you can do something that skips elements. Now, here is the first big difference between for I and for each. In the code up here, where we did the for each loop, I could not skip states, right? I could not skip states because semantics of for each says state takes on every single value in the list one at a time, one time, and I can't skip. So if I want to do something with some of the states but not the others, I can use a for I loop and vary the hop count. I cannot use a for each loop. A for each loop is only used if I want to do something, the exact same thing, with every item in the list one time. If I want to do something with some of the items in the list but not others, if I want to do things multiple times, that is a for I loop. That's the difference between these two loops. Now, it does turn out, as I've shown, that you can, what you do with a for each, you can do with a for I, but that doesn't matter. You know, they're still separate ideas. There's some limitations we'll get into. But a for I is more general. So for I, more general, you can skip. For each, you can't skip everything once. Now, can I go backwards? For I in range 0. Now, this is not going to work the way I want it to, so I'll illustrate this. What if the hop count is -1? Can I go negative? Let's try that. In this case, it didn't do anything because it started with I as 0, and then it decremented by 1, and it said, if you're decrementing, it's going to stop immediately. If your hop count is negative, it stops when you're past this, and so it didn't do anything. Suppose instead I said, for I in range, length of states -1, 0, -1, -1. And I'll explain why I did this in a minute. This has the effect of printing the states in reverse order. Why? Because you start with, again, this first value, this first item is the initial value of I. So length of states is 50, -1 is, is 49. So this says start with I equals 49, print states of 49, that's the last item, that's Wyoming. Then decrement by -1. Well, 49 minus 1 is 48, so now print states of 48. Then print states of 47. I said stop when this gets to be -1. Do not execute when it is -1. Here's why. Suppose that I had said stop when I is 0. Remember, this will not execute, this loop will not execute when I takes on this value. When I takes on the value 0, this will not execute. So when I run the loop, you'll notice I stop at Alaska. Okay, states sub-0, Alabama never gets printed. That's why you actually, if you're going negative, if you're going backwards through your list, you have to go to -1. Otherwise, it will not execute and print the sub-0 element of the list, the first element in the list. Similarly, up here, I said length -1. Why didn't I just say length? And here's why. List index out of range. By the way, this is a very common error for people to get. It happens a lot. List index out of range, because we started with length of states equals 50, and we said print state sub 50. There is no state sub 50. Okay. The highest number is always length -1. So if you want to go backwards through your list, you have to start at length -1, decrement by 1, and then stop at -1 to make sure that you do this with 0. So you can go backwards this way, and we will in some examples later on in the semester, Monday specifically. We're not going to do today. We'll have some examples where this is really important. If you're going to go backwards, do it this way. This is an illustration of having this hop count be negative. You go backwards through the list. If you're going backwards, remember when I did this, it didn't work. It didn't print anything. It didn't crash, but it didn't print anything. If you're going to have a negative hop count, this has to be greater than this. Okay. Now, everything I've talked about, I've given you in this for I loop all 3 values. You do not have to use 3 values in the range statement. You can use 2 values, or you can use 1 value. 2 values. Let's see what happens. For I in range 0, length of states. Now remember, going forward, we use length, not length minus 1. Okay, let's do this. It printed out every state. It didn't miss any. If you use 2 values, Python interprets that the first as the starting value, and the second as the stopping value. The hop count, the missing third value defaults to 1. So if you just give 2 values like this, Python will always interpret that as start at 0, end at length of state, and the missing value, the hop count, is always +1. Okay. If you use 1 value, you see, it still prints every state. And the reason is, if you provide only 1 value in the range statement, Python interprets it as the stopping value. By default, the starting value is 0 and the hop count is 1. So as I said, computer scientists, we like to be lazy. You can use default values. If you want everything printed, if you want I to range from 0 to the end, you could just say in range of the end, right? And it will default to 0 at the start, and it will default to 1 as the hop count. You don't necessarily want to do that depending on what you want to do, because print the 10th through 19th states. Okay, remember on Monday of this week, we talked about list slicing, getting the 10th through 19th states, or the 10th through 19th states. For I in range, I'm gonna not make this tricky. I'm gonna say print the states in indices 10 through 19. Okay, I'm not going to make you think about, wait a minute, the 10th state is in index 9, so let's skip that for now. So for I in range, start at 10. Now, I want to print 19, so I'm going to say stop at 20, and I'm going to let the hop count default to 1. And I want to print I and states sub I. Okay, I'm going to print two values on each line. So if you want to do this, you print the integer. The comma causes the print statement to output one blank space. So the 10 is the integer I. The comma is one blank space here, and then the value of the state. And so printing the states in indices 10 through 19, you say start at 10, do not go when it's 20, and the missing hop count defaults to 1. So you don't always want to start at 0, depending on what you want your code to do. You want to go from 10, you want to go to 20, you want to go from whatever. This is how you do it. Okay, let's go back to the slides for a little bit, and then we'll get into some more complicated examples. The key thing is, after tonight's lecture, you can write some really good code. What this slide just says is it takes a starting integer, an ending integer, and a hop size, take you from 1 to 2, hopping by 3 each time. Again, it doesn't have to be an integer. It's confusing if you're not. If you give one argument, it's just the end of the range. The assumed start is 0 and the hop size is 1. That's the default. If you give 2, it's the start and the end of the range, and the hop size is 1. You cannot specify the hop size unless you specify all 3 values. If you want to start at 0, go to some place in the middle, and have a hop size of 2, you have to say start at 0. You can't let it assume default to 0. Okay. So this is a for I loop. Here is the key. You can modify the list in a for I loop. You cannot modify it in a for each loop. So I don't want to mess with states right now because I'm going to pretend it's a constant. So I'm going to define a new list variable, and I'm going to call that numbers. It's going to be a list of integers, and it's going to be the first few squares: 1, 4, 9, 25, 36, 49. These are the first 7 perfect squares. Okay. Now, what I want to do is I want to replace each list element with the cube. So in other words, I have 1 squared, 2 squared, 3 squared, 4 squared. I want to have a list that says 1 cube, 2 cube, 3 cube. Okay. For I in range, okay, move this in. Provide some more background when I post these. For I in range length of numbers. Okay, so I'm going to start at the beginning and I'm going to go to the end. Numbers sub I is going to get replaced by, going to get assigned the value of numbers sub I times the square root of itself Okay, this is producing the cube. So I had squared. The way you get the cube of something, if you've got squared and you cube it, you take its square root. That's the actual value, and then this gives you the thing. Or I can make this simpler. I'm gonna comment that out. Here's a simpler way to do this. Numbers sub I equals I times numbers. There we go. That's simpler. That's more straightforward. This is just a case of I have the square. To get the cube, I just multiply it by the same thing. And now I'm going to execute this code. Hope I haven't made any typos. And now if you look at it, that's the wrong answer. Because the problem I had with this code is that this should not be I times numbers. This should be I plus 1 because I started with 0. So let's try this again. As I said at the beginning of this class, you're going to see a lot of debugging, what did I do wrong, errors. Sometimes I do that on purpose to illustrate you need to do this as a programmer. Sometimes I just mess up. We're going to acknowledge that this is just a mess up. Now let's look at the result. And it looks not right. This is indeed 2 cubed. This is indeed 3 cubed. That's because I skipped 4 cubed. At any rate, the bottom line, the point I'm illustrating here is that I can change with a for I loop I can change the list within the loop. How about with a for each loop? Okay, so let's write that. For num, that's a new variable name, in numbers, num equals num times, I'm just going to try to change it to double. Okay. And I'm not going to fight this that hard because this is the same value. Remember, I had changed numbers with the previous loop. Okay. So this numbers is the same as when I started. Okay. This is what I started with. Then I executed that code. And then I tried to change it. Well, that didn't work. What if I tried to change it another way? How would I do this? And the bottom line is, I'm not going to waste more time struggling around trying to show you to change this. You cannot do it. Other difference between a for each and a for I, you can't change list values using a for each loop. It's not allowed. It's not permitted. Python won't work. So that is another difference between for each and for I. If you want to actually change the values in the loop, inside the loop, you're going to need to use a for I loop. We showed with a for I loop, despite the fact that my math is terrible, that you can actually change the values of the list elements. For each, you cannot. So let me make sure I've covered everything. See what else I need to do. For each loop, that's an example. That's an illustration of what these are. For I is the key is the range, and get used to it. A notion of lists with different element types, which we're going to hold off till Monday on. The for I loop. The range statement, not all the arguments, these are the defaults. A for I loop iterating through the list. How to modify elements of your list. This is just another example. Okay, you can't do that. and some examples of how to do things. And now I want to spend some time. You can use for loops with strings. We're going to hold off on that till next Monday. What I want to do now is write some more programs that require us to think. Here's my list of states. I want to write a for loop that prints out each state that ends in A. Okay. In an A. For state in states. If. Now, how do I tell if it ends in A? So the last value equals, remember, double equals not assigned, A, print state. Otherwise, do nothing. Okay, this is a for each loop, which if I haven't managed to mess something up, will go through my states and print out all the ones that end in A. Alabama, Alaska, Minnesota, Montana, and there they are. The states that end in A are Alabama, Alaska, Arizona, California. Arkansas did not get printed. Colorado did not get printed. Connecticut did not get printed because they don't end in A. Maryland did not get printed. It doesn't end in A. That's how to do it with a for each loop. The same with a for I loop. We have to go through and test every value. For I in range, length of states. If states sub I sub minus 1 equals A, print states sub I. And this is a whole lot easier to get wrong. So let's make sure I've got it. How about that? I got it right. That's this is a whole lot easier to get wrong. Okay. So what happened here is, again, I said for I in range, length of states, I assume starting at 0. Okay, the default value is 0 to start, and the default hop count is 1. So go until you hit the end. And now I wanted to look at state sub I. State sub I is a string. So state sub I is a string. And the last character in that string is -1. That's character -1 in the string. Equals A. Then I can print it out. Okay. So that's a for I loop that does the same thing as the for each loop. Now, what if I want to say print it out if it ends in a vowel? If the state ends in any vowel, print out the state name. For the purposes of this, we're going to say vowels are A, E, I, O, U, and if it comes at the end, Y. So to do that, there's a couple of ways we can do it. We're going to use the for each loop just because it's a little easier. For state in states, for each loop, we can do the for I exactly the same way. If state sub minus 1 equals A, or state sub minus 1 equals E, or state sub minus 1 equals I, or state sub minus 1 equals O, or state sub minus 1 equals U, or state sub minus 1 equals Y, not T, Y, colon, print state. Okay, so this is what I call the hard way, because you have to write that fairly complex Boolean statement with all the ORs. Let's try this again. Copy. And now we can see that this added Tennessee, which ends in an E. It added Ohio, which ends in an O. It added New Mexico, which ends in an O. So it added New Jersey, which ends in a Y. New Hampshire ends in an E, and so on. So this is how you would print out all the states that begin or that end in a vowel. That's the hard way. Here is an easier way that uses lists. Let's define a list called vowels to be the list of A, E, I, O, U, and Y. So we have defined that list. Now, how do we know that something is equal to this, or it's equal to that, or it's equal to this, or it's equal to that, and so on? The answer is, if it's equal to any one of these things, then it's in the list. So now we can use that, and we can say for state in states, if state sub minus 1, the last letter, is in vowels, print state. So here we can use lists, we can use in, and we can do the same thing without that hideous Boolean expression. Oh, sorry, because I didn't copy vowels. And here we go, we see it works. This is what I call the easy way to do the same thing, okay? This is a way to use lists and use in to avoid having to use this hideous Boolean. So it's a way of simplifying your program. Now, I could have, if I wanted to, for state in states, if state minus 1 in, and put the list directly here, I could have done that. And presumably, again, presuming I haven't messed anything up, let's try this again. Let's try this again. It works exactly the same. Okay, so I could have done this rather than above, where I defined the variable called vowels, which could be a constant too. I didn't have to make a thing. I could have done this. This is not good programming practice. Why is this not good programming practice? Well, let's get back to our original definitions from earlier in the semester. This is a literal. This is a literal value. It is exactly this. It is exactly the little a, exactly the little e, exactly the little I, exactly the little o, etc. This is a literal that may or may not make sense to people. Yeah, a lot of people whose first language is English would look at that and go, oh, that's the vowels. Okay. But you should try to avoid this. So yes, it will work, but this is not necessarily good programming practice. It's much better to do what I did up here, where I said, here's what vowels are, and then if state is in a vowels, then that's fine. That tends to be more clear and also easier to do the coding. So it's just a habit to get into to declare this. And again, here I declared it a variable. It's a variable because it's lowercase. I could have declared it a constant using all caps. I chose not to. That's fine. How would I then print every state that begins with a consonant? It turns out I can define consonants to be the list of B, C, D, E, etc. That's fine. It would work. But I can use what I've already got. I don't need it. If it's not a vowel, it's a consonant. So I know that if it's in vowels, it's a vowel. If it's not in vowels, it's a consonant. So I'll do it this way. For state in states, for each loop, if state. Now, we said begins, not ends, begins, so state sub 0, not minus 1. Now, if it's in vowels, that's going to be a vowel. If I want it to be a consonant, I'll just take the not, the logical falsity. If not, state in vowels, print state. So I don't need to define this whole list of consonants because I know that if it's not a vowel, it's a consonant. Okay. So if it's not in, if the letter is not in vowels, then it's a consonant. And let's make sure this works correctly. And it appears it does not. What did I do wrong? I'm printing everything. Okay. Let's debug this. Okay. What did I do wrong? For state in states, if not state 0 in vowels, print state. Okay, let's take the not off and make sure that works. Let's try the ones at vowels first. Figure out what I did wrong. Or state in state if state 0 is invalid. Okay, let's see. What's vowels? That's fine. To figure out why this is wrong. Okay, so we're printing out the state value. So the state's, case. That's my problem. I'm comparing uppercase to lowercase. That's why it's failing. Python is case sensitive. Vowels are the lowercase letters, and I'm comparing this. So let's set it back to what I wanted. I've got to remember that states begin with uppercases. I'm going to redefine vowels to be the list of uppercase A, lowercase a, uppercase E, lowercase e, uppercase I, lowercase I, uppercase O, lowercase o, uppercase U, lowercase u, and then Y as a beginning consonant, a beginning element. There are no states with Y, so it isn't going to matter. You'd have to decide if you want an uppercase letter to be a, you have to decide if you want an uppercase Y to be a vowel or not. Your choice. Here we go. Let's make sure this works now. And indeed, it looks like I actually succeeded in getting this to work. This prints out just the states that begin with consonants when I took into account that that Python is case sensitive and I began my states with uppercase letters. So this is a way of doing some programming tricks using using lists, and using loops. Again, to do that with a for I loop is a little bit more complex, but I showed you how to do it. It all works the same here. So, wrapping up tonight's lecture, here are some examples that we worked through. And when I say the easy way, the hard way, and the medium way, the hard way is that ridiculous Boolean statement with all the ors. That's the hard way to do it. It works. It gave me exactly the right answer. We're fine. But that's the hard way. The medium way is what I showed you as not good programming practice, where I said in, but I gave the literal list right there. The easy way is to declare the vowels as a list, a variable or a constant, and you're good to go. Walking through that, strings, the last thing, you can use a for loop with a string exactly the same way. Suppose I have this thing from Mary Poppins. I knew I was ending too early. I had skipped something. Okay. And by the way, a lot of times if you copy things, you get smart quotes, which causes problems. So let's fix the quotes. Now, for each loop, I'm going to print each letter in the string on a line. First, I'm going to do with a for each loop. For character in Word, print character. Okay, so let's make sure I do the right thing with Word. And now we can see basically that what I've done is I printed each letter of the word on a separate line. That's a for each loop. The point of this exercise is to show you that for loops work with characters in strings exactly like they do with elements in lists, except that you can't change the string. You can access it, you can't change it. A for I loop to do the same thing. For I in range, I'm going to skip 0 and I'm going to skip the hop count, and I'm just going to say length of words. Oh, it's singular word probably. Print word sub I. Okay. And this is going to be a for I loop to do the same thing as. There we go. That works. So getting back to the slides. Next Monday's lecture, we're going to show examples where the index is not an integer, where it's characters or things like that. We're going to work on various things with for loops, and we're going to start to get into while loops a little. I believe that you now have all the information you need to do the lab that was assigned this week. You should be good to go. Again, apologies for not coordinating that more carefully with Kevin and Mariah. That's on me. But we did cover that. Printing the even numbers between two integers, x and y, with a for loop, use a hop count of 2. How can we use range to go backwards through a list? We showed an example of that. You use -1. Largest, stop, -1. Print all the elements of a list with their index. We did that with states 10 through 19. Did that with examples, modifying lists with a for I loop. We did that. Not all the arguments, that's the range. We did that, we did that, we did that. Lists with different element types, as I said, we're going to cover that in detail on Monday. And now we're back to this. So I think we've covered everything, and we're just about at time. I've got 5:13. I will be on for about the next few minutes. If you have any questions other than that, enjoy your weekend. I will see you back here next Monday.
Thank you, Professor.
Thank you. No problem.